Welcome to our next lecture of NDT. So in previous class we have discussed about radiography, what are the various techniques which are used in radiography. In this lecture, how the inspection of radiography is going to be done, that we are going to discuss. So we have the inspection of radiography can be done by doing various type of things. First thing is a single wall single image technique, and another is double wall double penetration technique. In double wall penetration technique we have another three types, that is double wall single image and double wall double image and double wall superimposing. So what is the main difference between the all these things is nothing but in single wall single image technique we will be having one source and one image. So one side of the wall we will be having a source, another side of the wall we will be having an image. So source will be kept at some distance. So when a source sends a signal, we will be receiving the image of the source on which it is being projected. So this is generally used for thin plate cylindrical shells like this. So another thing is you can even keep the source if the inside source is accessible to you. For example, a tunnel pipes, whereas the outer surface cannot be accessible, you cannot keep the source outside the pipe. If it is a tunnel, you will try to keep the source inside the tunnel and the image is received on the other end. So this can be done by using for tunnels. Okay. Next is parametric technique. This is nothing but where the surface is the source is traveling inside a hollow tunnel, through which the whole length can be even measured on both the sides, can be done by using in this the source is kept at one side and the images we can be received as a whole image, a circular image will be received. Whereas double wall double penetration technique, in this when the when the inside surface is not accessible, this is a whole pipe. If the fluid is flowing through the pipe, you cannot go inside the pipe and you cannot take it out. So during this we can use double wall penetration technique. In this double wall penetration technique, you can even use a single image, you can use double image, you can obtain a superimposing image. So if you want a single image, so while keeping on one side of the source, you will be having a one side of the pipe, you will be having a source, that is nothing but radiography source, either it may be gamma source or a X-ray source. On the other side, you will be having a image receiver, where you will be receive the image of both the pipes. So similarly, most probably it is done for a small diameter like 90 mm. So what happens means, here the rays are exposed to this area very small quantity. So but whereas here it has exposed to a larger area. So we can able to observe that the image of only the other surface, but whereas this will be obtained only a less quantity. In this the source will be kept much closer to the outer diameter. Okay. So next, in double source double wall double images, what we are doing is one side will be having a source, the whole source will be kept at some distance away from the outer diameter, it will be continuously exposed. So both the areas will be both the image quality indicator is used for the film, so that we can able to interpret the two surfaces, that is outer surface and the other side surface. Both the surfaces can be studied. Superimposing technique. Whereas in superimposing technique, what we generally do is you will be having a source on one side, and we will be having a image receiver which is at an angle of 120 degrees apart, so that we can expose to different areas, we can able to obtain the image in different ways. So next thing is real time radiography. What is real time radiography? Is nothing but we can able to obtain the images in two ways. One is stationary images, one is dynamic images. Stationary image is nothing but when the object is stationary, then we are going to obtain an image of using a film radiography, just like your cameras. So if you use a normal digital camera or any mobile camera, you can able to see some stationary images. If some person starts moving, you cannot able to capture those things, but by using some extra type of cameras where you can able to analyze that motions also. So in film radiography, if it is a static mode, we use film radiography. If it is a real time radiography, then we use a dynamic mode. Okay. So what is the general way of using the X-rays or gamma rays to obtain the image? Is nothing but we will be having a source. So that source will send the signal, and we will be having an object which is exposed to the X-rays, and then we will be able to make them to fall on a fluorescent screen. So where the screen will try to reduce the image intensifier, means it will try to improve the quality of the image then it is able to get on a monitor screen, or you can able to obtain on a film copy. Okay. So the real-time radiography has the advantage of high speed and low speed inspection, means when you are moving faster, when you are moving slower, we can able to obtain that, but whereas in stationary we can able to obtain only when it is stationary. So the radiography concept can be applied to a case of microfocal up to 100 microns. Okay. The real-time microfocal radiography is the zooming is done by dynamic positioning of the object in manipulators between X-rays and the images. We can manipulate the objects. Okay. So the films the films generally used in radiography, they are very similar to photographic film, which you generally see if you in previous dose. In my childhood we have seen a photographic films. Backside the camera we will be having a reel which we are going to what do we say, that film is going to be watched. From that you can obtain the negatives. We generally even call this as negative images. So these are similar to photographic film in that there is a central carrier called as film base. So that black thing which you see in generally in X-rays is called as a black face, which is having a thin sheet of polyester. This is normally a transparent and serves as a carrier for the chemical reactives. So the emulsion is coated on both the sides of the film, which is generally called as silver hydride, which is used to record the images. So the emulsion is usually coated on both the sides by using a flex transparent blue tinned layer. So that is nothing but a silver film highlight which is coated with the blue tin. Tin is nothing but a element which is based off a thickness of around 0.012 on either side of the film. This is the generally your film. On both the sides you will be having a protective layer which is a tin material. So though the films are made of sensitive for both X-rays and gamma rays, they are even sensitive to they can even able to capture the visible lights also. So to avoid that, we generally this can react with any of this, the silver highlight or the things which are you are having, the halogens which you are having on the film can even can be reacted with X-rays, gamma rays, and even some high frequency lights. Okay. So this change in the small change in the nature of the halide can be visualized in the film, and the film is exposed to chemical solutions that is nothing but the developing of the film to formation of the image, where we can able to see the reactions which are exposed to the X-ray. They will be in a form of one way, which are not exposed, that will be formed in another way. Okay. This completely depends upon the film speed, how the film is going to be captured. We have two film types, one is high speed film, another is low speed film. What is high speed film is nothing but the reaction of the grains which are present on the screen can be reacted at a faster rate when you are trying to keep some what do we say, reactants on the film. Okay. So the grain, if the grain size is thin, very small, it takes lot of time and the quality of the image will be much more. If it is a high speed film, the image obtained will be the time exposed will be much less, but the time quality of the image will be less. So how the speed of this film is calculated is nothing but the speed is generally defined as a density recorded on the image or the film resulting the radiation from the input. So what radiation you have sent, how the film has received, how much amount of density has received, and what is the resulting film it has given to you. It is measured in terms of inverse or exposure to the produced radiography. So the film selection, how the films has to be selected, we have some criteria. So first thing we have to see is what is the composition, what is the shape, what is the size of the part where we are going to use. Sometimes we even use for what is the weight of the object, where is the location, where how the film has to be kept. So that we have to see where, in which location we are going to use those films, that we have to see. Next thing is the type of radiation, whether you are using gamma rays, X-rays, or high capacity gamma rays, or high capacity that is nothing but high X-rays or low X-rays generally we see. Next is what is the kilowatt which you are using to generate the X-rays, and relative importance of high radiography details, that is nothing but economic results has to be seen. Next thing is film packing. If you see that film packing generally, if you go for an X-ray, after doing that X-ray, that will be kept in your envelope. Why you are doing this is nothing but this film has to be packed very properly. If it is not kept properly, the outside air or the contaminations on the air can able to react with this film. So that has to be avoided. So the radiography films can be purchased in different packing options that is available in varieties of sizes you can see. So the film photography, that small what we say in old cameras, you might have seen a photography which is in a round form, which you pull, you can see the whole film Similarly, if you go for the X-ray shop, they will be having a big X-ray films. So different types are there. In industry X-rays are also available in different forms, either in terms of sheets or either in terms of a what we say, they are enclosed in a tight envelope so that it is not exposed to any other things. The films can be exposed from either side without removing the protective pack. So the packed films is also available in the form of rolls, that I have given the example of your old camera scenes. So how the film handling is done? So X-ray film should be handled very carefully to avoid the physical strain. Generally, even if you see that what we say, the person who is developing the film, he will never touch the film with your normal hands. He will take the film into some chemical agents, then he will be wearing some gloves with him, so that he prevents the reaction between the hand and the film. Those impressions or the dust particles which are present in your hand can even react with your chemicals present on the film. Okay, so these films has to be seen on some screens. So there are different types of screens which are generally used, that is nothing but lead screen, steel and copper screen, fluorescent screen, salt screens, and what we say is nothing but fluor metallic screens. So the lead screens are nothing but used under the impact of X-rays and gamma rays, which is having a lead screen emits electrons which generally reacts more with the film, which when you are using a film on a screen where it has to be projected, so that is having a lead which will release some amount of electron. This electron reacts with the film placed between the two layers, and it tries to what we say, intensify the image of the thing which you have received. So this method of intensifying is used when the range of voltage is in between 80 kilovolts and 400 kilovolts. So the intensifying screens are made up of two homogeneous sheets of lead foil, that is nothing but two same type of lead foils are used, struck on a thin base such as a sheet of paper or cardboard between which the film is placed. So on the either side you will be having a lead screen to the film. So film will be kept in between the lead screens. So the electrons which are emitting from the lead will go and react with the film in between them. Okay. So the thickness of the front screen must match the hardness of the radiation being used, because the whole radiation, if it is falling on the screen, the screen is having n number of chemical reactions, it will completely react. If the screen is not a thicker one, or the thickness of the screen is not proper, if it does not match the hardness of the what we say your X-ray radiation, then it will even melt sometime. Okay, the surface of the lead screen is polished to allow our close contact of the possible with surface. Okay, the flaws, scratches should be removed. Next is steel or copper screens for high energy, where that I have told high energy X-rays has to be used where lead is not possible, the best option, because lead even can what we say will give large amount of electrons, because of which the whole film may be damaged. So with cobalt 60 gamma rays, copper or steel has to be used where the megavolts of X-rays are being generated, which is around 5 to 8 megavolts. Next is fluorescent screens. These are generally used in your X-ray devices, that is nothing but you take X-rays now, so that X-ray is having the fluorescent screens. So is used to indicate the characteristics of substance to instantly emit the light under the influence of electromagnetic radiations. Okay, this phenomenon is more made use in the film radiography. Okay, film based radiography, stationary radiography. Okay, clear. Next, salt screens. Salt screens are nothing but the fluorescent screens consisting of a thin flexible base coated with a fluorescent layer made up of microcrystals or suitable metallic salts. That is nothing but metallic salts means metal salts, don't consider as any other salts, which are rare earth materials, generally calcium, tungstenate, which fluorescence when subjected to radiation. These radiations make the screen lighten up. So what is the importance of these screens is nothing but the screen, when the screen will be first exposed to the X-rays, the screen will release some kind of what we say, either electrons, we can say, either some kind of radiations which make them to intensify the image. Okay, so the image quality is increased by using the screen itself. Here you can see the image quality, however, is poor because of increased image unsharpness. Okay, so the types of films, we have different types of film. One is single coated, double coated, screen films, non-screen films. These screen films are nothing but on the films there will be some screens, like we have seen that different types of screen, fluorescent screens, either it is salt screen, copper or this screen, either it is lead screens. So So without non-screening films will also be there, which are used in rare cases. So on the basis of types of emulsion coating, what type of emulsion coating we have given, either it is a blue light or a green light, if some orthochromatic lights like green lights, dark lights for you, if you want to see in a dark region, so how this is to be done. Okay, for example, every time you cannot be using the radiography only in the bright light, sometimes you will be using in a submarine. So if it is a dark room, then how you are going to see. So types of films, the films which used for use with salt screens are also known as salt screen films. The films for use with metal screens are called as without metal screen are called the direct films. The films used for special purpose are called as single emulsifying films. So salt screens, we have already seen that it is using some kind of salts which are nothing but metallic salts, that is calcium tungstenate, which I have directly seen. Next is direct films are generally used as metal screens where the metal is directly coated. This group covers the industrial film, most of the industrial and some of the medical films we can see. The contrast of the industrial film increases the density increases, whereas the medical film readily reacts to the maximum with increasing the density. So it will improve the density of your image. Okay, clear. The special purpose film, this finds the less frequent use in the radiography, that is photographic films. These films are used in photographs, which I have given example, fluorescent screen on X-rays. These films are usually sensitive to blue or blue-green glow emitted on the screen. You might be seeing that like what we say, under the some paragraphic glasses we can able to see these images. X-ray paper, instant cycle X-ray paper are the latest addition to the film of X-ray. When used in an instant cycle processing unit, this paper develops the completion like your litmus paper. Okay, film processing, how we are going to process the film. So the generally, if you see for any of the normal films which you are using, I'm been giving the example of your camera films. Those people will take that camera film and they will react with some of the agents, and again they will send it to another liquid chemical agent, that is emulsions. Again they will be washing it with water and they will be drying it for some time. Same thing happens here. So when X-ray or gamma rays of a light strikes the crystals or the grains present on the film, some of the bromine ion are liberated, leaving the silver, because we have already discussed the films are having been made by using silver halide crystal. Silver halide means silver halogen. Here halogens are either chlorine, chromium, fluorine. So basing on the type, here silver bromides or silver chlorides are generally used because fluorine is a high reactive element, electroreactive elements. So halogens are nothing but chlorine, bromine, so rare which are very much near to the inert gases in your periodic table. The last elements before the inert gases are halogens. So example is chlorine, bromine, iodine. Next is your fluorine. So these are the few examples. So among this they have used silver bromide, means that bromide ion will be coming out of the silver halide and the silver ions will be left on that. So in this condition the radiography is said to be containing the latent hidden images. So these images will be held out as the silver ions are kept. Because of the change in the grain, it is virtually undetected. So when this film is exposed, these several electrons which are present in the screen, that will be reacting with your silver, metallic silver, and these will be exposed on the radiation. So how the development is happening is, the developing agent gives up the electron, that's why I have been telling. So this electron reacts with the silver halide and it will create a metallic silver. Purely silver will be formed and that bromide will be coming out. So the grain that has been exposed to the radiation develop more rapidly and gives enough time to the developer to convert the silver ions into silver metals. Okay, stopping the development. How we are going to stop this development to have further formation of silver is nothing but we will take this and keep this into a water and dilute it by using by washing it. Okay, so when you are diluting it, what happens, the electrons which are formed, they will be washed away because of the dilution. Okay, the unexposed silver halide crystals are removed by the filling bath. That when you are keeping it in a bath, those silver halides which are not formed, they will flush off with the water. That is nothing but silver halide crystals leaving behind the silver on the paper. Okay, so after that we are going to dry it. After washing it, we are going to dry it where we are going to image. So now viewing of radiography is nothing but how we have to see the film. So after how we are going to process this image, after processing we have to see the image. For example, you go to a doctor, if you take the X-ray, he will not see it in with his naked eye. He will be having a exposure, light exposure, where he will attach that film to that light thing. So there he can able to visualize the image properly. if you see directly in a normal day, you cannot able to see the difference. So he keeps that image onto the some glass illuminating light, where he can able to easily observe the cracks in your bone. So similarly, after exposing the film or after processing of the film, it has to be seen under some radio box, or that is light boxes should be used. So in addition to provide the diffused adjustable lights are there, by using which you can able to see the intensifying images. Okay. So how we are going to interpret and evaluate these test results? So for the common term for interpretation is nothing but film viewing. How we are going to view the films? The film viewing in fact means that the evaluation of the image quality or of the radiography. So for this purpose, the film is placed in front of the illuminated screens that I have already said. So the edges of the film and the areas of low density need to be masked to avoid the glaze. So which are not exposed, those has to be masked, means those has to be covered, because the image where the silver halide or silver is formed, that has to be seen in a brighter way. Okay, so that we can avoid the the conflict between the image and the other activities. Okay, so the light of viewing box must be diffuse and preferably white. Most of the time they will be using white color lights. The radiography should be viewed in a dark room instead of seeing in a very bright room. So the care must be taken that the little light as possible as reflected has to be seen on the film. So if the film viewer enters a viewing room from a dark, means he should not come from a sunny day into the room, because his eyes cannot adopt this darkness. Okay. Next, this film interpreter. So film interpreter is nothing but how to understand the film. For example, there may be a crack, there may be a small line. So even that line will represent few things in for example, in metallurgy, if you see, the cracks may be because of the extra material, maybe because of the holes present, or because of the improper welding. So how to identify these, or how to interpret the images which are observed on the film is nothing but that. For that we have a huge courses are there. So the person who is understanding this should be a well qualified person. So there are different setups, or different references which has been used in NDT technique. Either it is AST standard book or European NDT industry tech will give you some standards. Basing on that standards only you can decide. So these are the few interpretation which I am going to show. Generally, if you see in welding, there will be when you do radiography, you may see this kind of images. So that means there are some cold labs. That is, when the material is cold, welded is done. So after welding, there may be a cold labs formed. Similarly, if there is some porosity is there, the porosity will be observed like this. If there is clusters formed, cluster is nothing but a contamination is happening from the moisture, then it is observed like this. If it is like slag is extra material is formed on the weld, then it is formed like this. If it is some cracks are happened because of the welding, you can observe two type of cracks. One is longitudinal, another is transverse crack. Okay, so the radiography interpretation in casting, if you see, so this is generally happen in casting. We know that casting will have some gaps, porosities, blowholes we generally see. So the blowholes will be observed like this. Next is sand inclusion or dross. That is nothing but metallic oxides are formed, which are generally observed in this as a dark things. Next, cracks can be observed in the blowholes like this. Okay, so these are the different inclusions. So what are the safeties which you have to use in radiography is nothing but in general, when you are going for X-rays, from the first class I have been saying that you should not be continuously exposed to X-rays or gamma rays, because you may get skin cancer, you may get various types of health hazards. So pure security has to be taken. The person who's working near the the source, he should keep himself away from the distance from the source. All the he should wear some kind of a protective surface, so that he can avoid from the radiations, so that he should be standing away from the source. Either he should the time taken should be much, and he should use some kind of shieldings. So shieldings are nothing but some people will have that black cloth around them when they expose that, because the black cloth will absorb all the radiation and you will be exposed to that. Okay, so these are the few things which you have to understand about the radiography. And what are the applications? If you see, it can be used to inspect most of the solid metals, both ferrous and non-ferrous. It can be used for inspect the conditions and proper placement of components, for liquid measurement, used for intensifying of casting, weldments, everything can be done on this. Either you can able to see the defects and cracks, broken wires, everything can be done by using radiography thing. Only thing is that these are the high X-ray, high range waves which should be avoided, either it for a material or for a men or material. Okay, so much care should be taken, and the application should be very much. For example, here can be inspected to use semiconductor devices. When you are using semiconductor devices, you cannot go for high X-rays, because high X-rays will be having high much amount of high energies which can able to even melt the small diodes present in it. So with this we can even complete our 4th unit. We will be continuing with our 5th unit in next lecture. So with this, our 4th unit has been completed. As your exams are very much near, please try to go through all the topics. If you have any doubts, we will be trying to clear your doubts as early as possible. Thank you.